Okay, I hope you can hear me well. So I will give you in this slide deck on essentially an introduction into this workshop and try to sketch a bit of an overall picture where then the different bits where you will be exposed to during this workshop fit to. So when we talk about, say, infrastructure which we're working on, then of course there are, say, a lot of details involved. So I prefer now here to think about it in a more abstract level to also simplify think a bit, and to talk about what is the conceptual approach on how to design this in a way that we can also have this as a sustainable effort which would stay there for a longer period of time. And for this, we are working towards, say, a separation of concerns in the sense of having here at the lower part the infrastructure services, which can, for instance, be HPC services, cloud services, storage services, but also specialized computing services. I mean, Katrin mentioned already the Neuromorphic Computing systems will play an important role in this training event. And they are not necessarily at the same location. They may be, say, geographically distributed. And that means that they are operated also by, say, different organizations. And something which you observe today is that when things operate by different organizations in different control domains, then you typically need to have your separate accounts at the different sites, and also resources are managed differently at the different sites. So what we try to put in place is a set of federated infrastructure services, which in particular includes then also the necessary services for authentication and authorization, as well as also for resource management service. Now, one thing to notice here, I mean, what is here marked in orange is quite generic. There is not so much here which is really, say, neuroscience specific, and that is really, say, the purpose, because when we look at it from, say, a resource provider's perspective, and I'm, say, currently working at the Jülich Supercomputing Center, we have to be careful in the way of how we organize ourselves so that we have a certain level of consolidation in order to make, say, an efficient use of the resources which are available. So that's why we prefer here to keep things generic in order to be able to service then different research communities. And for sure, the neuroscience community is one of the very important ones. Now, on top of that, we expect in future more and more science domains to put in place their own science domain specific services. And this is now an area where also thanks to the Human Brain Project, the neuroscience community has, let's say, a very good opportunity to be ahead of other communities in putting these kind of services in place, which is a lot of work. There's a lot of complexity in there, so that they facilitate then shared access to data, collaborative working on top of the federated infrastructure services which are there on the bottom. So this workshop is very much about, say, looking at these different pieces of this more abstract architecture, and to train you in how to actually use them. Now, one thing which is important to realize is that there are, say, also differences in terms of the audience. So on the top of this picture, we have end users. And part of this training is clearly, say, looking for end users. I mean, they may either connect to some of the platform services, but there's certainly also, say, well, you might call it power users, which then directly connect to the infrastructure services, say, if you like, bare metal, to get, say, best possible performance. But then we have, and I expect also many of you here in this audience, are more, say, service developers. That means are developers of platform services which then run on top of these infrastructure services in order to provide then services to end users. So it's sometimes important to say distinguish that, because not all of the infrastructure services are really appropriate for, say, all the needs of the end users directly, but they may be more useful for the service developers. And so that's why I also would like to recommend to you, I mean, do not necessarily focus immediately, say, on the technology and believe somebody told you this is, say, the best possible technology to use. But really enter also in a dialogue with us and try to also explain in what you want to achieve. So that helps also us to give you, say, guidance in what is the right service level to also enter for you. So now let's look at the different bits and pieces of this picture. Now here at the and I focus only on those bits and pieces which will be covered here in this training event. And here on the bottom, we have the HPC cloud and storage services. Now, to be, say, more precise, we will focus in this training event on the HPC and cloud services, but obviously the storage services will play some role there. And in the upcoming EBRAINS architecture infrastructure, it is, say, Fenix, or more specifically, the IC project, which took the task of providing these services. Just to explain a bit the difference about Fenix and IC, Fenix is a more long-term, say, commitment of 5 supercomputing centers which want to collaborate on providing infrastructure services along this picture, as it is also shown here on this slide. While IC is a specific project which is funded also in the context of the Human Brain Project, and through which we are providing dedicated resources to the Human Brain Project, so resources where you can apply for making use of them. And you will learn about more about that later. Now, who is behind Fenix? Now, as of today, Fenix is implemented by 5 supercomputing centers. And you can quickly see here that they are really dispersed all over Europe, starting with the Barcelona Supercomputing Center in Spain, SAA France, Jülich in Italy, CSCS in Switzerland, and the Jülich Supercomputing Center in Germany. And they offer, say, different kind of systems, so that's something you can take benefit of. I mean, another argument for actually distributing this kind of services is also that, as also Katrin already highlighted, some of the data sets are going to be really, really big, and you don't want to move them throughout Europe, but to actually facilitate processing of the data where this data resides. Now, currently we're talking about 5 supercomputing centers, and I also mentioned that Fenix is a more long-term effort, and we are not planning this to be, say, a closed club. Essentially, we are looking for other partners, and we are in the process of adding the Finnish Supercomputing Center, CSC, which is hosting, say, one of the 3 pre-exascale systems. So in this sense, we also, say, about to grow this Fenix initiative. Now, the key services which are offered by Fenix are starting with the computing services, where we have interactive computing services. These are, say, services where you can log into interactively into, say, dedicated servers, and from there have, for instance, access to large-scale storage systems, so to perform an interactive data analysis. You can log into systems, but you may also use then frameworks for interactive frameworks like Python Notebook. Then the second category of services which we offer are the scalable computing services. This is essentially, say, the more classical high-performance computing. So you are expected to put your jobs into a batch queuing system, and in order to make then to fill the systems in the best possible way, the batch queuing system then decides on when to actually process the work which you have then given to the supercomputer. And then finally, and that is part then of the more cloud type of services, we also offer virtual machine services. For the data services, we are, say, putting in place 2 types of data repositories. one class of data repositories we call the active data repositories. They are currently typically implemented by parallel file systems. Those of you who are already users of supercomputers know that there are, say, large-scale parallel file systems attached to these supercomputers. Now, these large-scale parallel file systems, they are optimized, say, for performance, and they are, say, also meant to be operated next to a large-scale compute cluster. They are not ideal when you want to share data in, say, a broader community. And for this, there are other, say, technologies which are coming from the cloud, which are much more suitable for this purpose. And that's why we put also archival data repositories in place. And these are going to be federated. So while the active data repositories, you can think about them as data repositories where you can host your private copies of your data. The archival data repositories are the repositories which allow you then to share this data and to access it through a cloud type of interface. We decided for the time being to go here for a Swift interface. Some of you may have heard of S3, which is, say, very similar, but currently we see some benefits, in particular when it comes to access control for using Swift in this context. Then, of course, you want to you have to manage the data, to move data, for instance, between active data repositories and archival data repositories. For this, we are going to put data mover services in place. They are not yet existing. They are currently being developed by an external contractor. We want this to be at the end a product by a company so that we have the right support then to operate this service and also after the end of this project. We also plan to put services in place which allows you to then identify where is the data stored and provide transport services for moving data then between different sites. So that's essentially about moving data between different archival data repositories. And then there are, say, the already mentioned federation services, which provides then, say, the authentication and authorization, and as well as the user and resource management. And that happens at a global level. But each of the sites, 5 sites which I mentioned before, will implement, say, all the services which you see here on the left, or there is also here in the bottom right, say, a picture which visualizes it on the top, the 3 red boxes, the 3 different types of computing services. So the scalable computing service, the interactive computing service, as well as the VM services. And at the bottom, the 2 types of data repositories. And you can see here already, say, the active data repository is directly connected to a high-speed interconnect to the scalable computing services. But you cannot necessarily expect to have access to the archival data repositories from the scaling computing services, because if you connect with a very large number of nodes to such archival data repositories, that's something where these technologies are not made of. Now, something which, of course, is important to highlight, I mean, all this will only work efficiently if they are connected by a network. So we have the high-speed interconnect to within the HPC sector, so which connects the scalable computing system, the interactive computing system, as well as the active data repository. But then we also have site-wide interconnects, which then is typically a bit of a slower interconnect, but from there you can also then connect to the external world. With that, I move to the next block here at the bottom, which are called here specialized computing services, but that translates here in this context to neuromorphic computing. And as Katrin already highlighted, we have within the HPP currently 2 neuromorphic computing systems, which are quite differently. On the left side, you have Spinnaker, which is installed at the University of Manchester. It's built on a Spinnaker chip, and you could argue in some sense it is more, say, a kind of a classical processor architecture, as it's still a von Neumann architecture. But it's very much a application or optimized for, say, doing, say, relatively simple operations, but extremely parallel, and all that interconnected in an application optimized communication network. So that's possible then to realize systems with 1 million cores, which is pretty large, say, if you compare it with other HPC systems. But of course, you have to be fair. This is now not an apples to apples comparison when you just count the cores. Now, brain scales at the University of Heidelberg is significantly different. Also here, there is a building block is a custom-made chip, but it includes analog computing services, and the chips are not as usual, say, created by cutting a wafer into pieces, but the wafer is left uncut, and so the communication is running through the wafer, and then you can build in larger systems by putting these wafers together, as it is also shown here in this picture below. With that, I come then to the last piece which we touch on in terms of this picture, and that is one of the more generic platform services, namely the collaboratory. The collaboratory is something which I consider is extremely important for these kind of infrastructures. Even so, it is, say, generic in the sense of that it's a web-based gateway, and you can think about many web-based gateways, but it is of obviously, say, very strongly also customized to the need of this community. But it and provides then, say, important methods or services to work then collaboratively. For instance, it provides you with access to controlled workspaces for collaboration and exchange. And just to give you, say, one example, that they can be public, but they can also be private. I mean, Workpackage 6, for instance, has also its internal collaboratory, which for those of you who are not part of this work package will not be able to access, but you can obviously access then other parts, because it's, and what is, say, very important to highlight, it's also here an extensible approach. It's an extensible framework that supports an integration of other community apps. So it's not supposed that everything comes then from the core development within the Human Brain project. So coming more specifically then to the agenda of this 3 training days, you will learn about the specialized computing services that are Spinnaker and BrainScales. Then next in the agenda, you will learn about, say, one of the platform services. That's, say, one of the core platform services. That's the collaboratory. And then there will be different talks related to the HPC cloud and storage services, one on OpenStack and the other on scalable computing services. And then there are other topics which is, say, related to the aforementioned topics. For instance, an important question which often comes up, is it possible to use, for instance, scalable computing services through the collaboratory? This is in some sense a bit of a sensitive issue, as say, the collaboratory is relatively open, and HPC tends to be something which is protected. But there are ways of how to facilitate it without, say, violating the security constraints. And then one thing which I would really, say, encourage you to pay attention to is at the end of this training event, there will be a presentation on how to get access, in particular to the HPC cloud and storage services. So I would really like to encourage you, if you have, say, a scientific problem where you think, okay, here it would be really important to have access to more resources. Don't be shy. Dare to think big. And really take into consideration that you are all eligible for applying for these resources. At the end, the decision is based on excellence. So, I mean, you will not be asked on what is your precision of how many PhDs you have done. It is at the end, people will only look at the scientific excellence of your proposal, as well, of course, as on the say, technical feasibility of what you want to do. And with that, I mean, I think many of you should have good chances of getting access to the offered resources. Now, in the final part of this presentation, I would also like to give you a little bit of background on who are the people behind, say, the services which are part of this training event, and that is Workpackage 6 within, say, the current running SDA 3 phase of the Human Brain Project, which has the title EBRAINS Computing Services. And I put here as a reminder for those who are a bit more familiar with the internals of the Human Brain Project, what are the objectives of this work package. So in the context of neuromorphic computing, we want to have, say, more improved online and interactive neuromorphic computing resources. So there's work both on, say, improving, say, the neuromorphic computing resources as well as on the access layers. Then with the federated infrastructure, that's mainly the HPC cloud and storage services, we want that they are, say, improved and adapted, and they really become, say, a sustainable infrastructure, which are then available to EBRAINS even beyond, say, the runtime of the IC project. Then Workpackage 6 is also responsible for facilitating collaborative workspaces. So this is about, say, the collaboratory, so to increase the maturity of these tools and to improve its integration then with the lower level infrastructure services, with the goal to reduce the barrier also to using then this research infrastructure. And then there is another activity which, if you like, is more a political activity, but it needs also, say, a strong reflection at the technical level, and that is, say, the efforts to get EBRAINS on the S3 roadmap. I mean, Katrin did already mention that. That's basically the strategy of the Human Brain Project and now EBRAINS to become sustainable beyond the end of the Human Brain Project. Now, in terms of the tasks which are in this work package, we have a number of tasks which are, say, still, say, oriented towards technology and infrastructure development, but it is the ambition of ending the Human Brain Project with an operational research infrastructure. And therefore, the focus now in this period of the Human Brain Project has to be more also on operation tasks. And that's why actually most of the tasks are focusing on operation. Then, of course, we have also tasks which are, say, dedicated to preparing the S3 proposal, as well as defending it then hopefully successfully in next year. And we are about now to establish then a new EBRAINS scientific liaison unit in order to have a better connection then also towards between the different science fields and the infrastructure services. And then obviously we also have a task concerned with management of this work package. Now, what are the organizations which are involved? It's say all the supercomputing centers, which I have already mentioned before, then CNRS, University of Heidelberg, and the University of Manchester. They are focusing on the neuromorphic computing. We have EPFL here in particular as being in the lead on the development of the collaboratory. And there are a number of partners which are involved in the context of the S3 proposal. And I would also encourage you, if you have any questions, you find the email here, and you will also find basically the people which will receive the emails sent to this email. So all nice people, no reason to worry with sending an email to this address. And with that, thank you for your attention.